I would like to remind you that for more Microsoft webcasts, you can go to microsoft.com/webcast. Thanks again for joining us for today's presentation, MSDN Webcast, Visual C 2010, Soup to Nuts, Part 1 Introduction. Now it's my pleasure to introduce today's presenter, Bill Steele. Bill, you have the floor.
Well, thank you, Ari, and welcome to this first in a whole bunch of Visual C# webcasts. Basically, this is a remake of the original, I believe, 2005 series called Visual C# Soup to Nuts. We are going to be covering all of the newest, latest versions of the language. And in this case, we're going to start off with a brief introduction today. We'll basically talk about the language constructs itself, and then we'll look at building some basic types of applications. There are basically 3 different types of applications that you would build with C#. And we're going to go ahead and build an example of each one of those 3. And then we'll talk about how we expand that out and where we'll go into the future with this series. So this will be a weekly series. And today is the first one, so let's begin. The first thing that we're going to talk about is the actual language constructs itself. What does the language look like? And with that in mind, we're going to basically look at the primary organization of the actual C# coding file itself, and we'll talk about the syntax that we use to actually build an application, and we'll learn about some of the important aspects that we need to deal with when we're doing an application, as well as we move later on, why some of these aspects are important. So starting off is a very simple method called main, and the text here says function, and technically it is a function. Any kind of code that you're going to write within C# is going to be contained within what we call a method, or a function, which is a block of code individually, separated from everything else in your code. And when we do that, we actually call it a function. Now, a function is actually separated from any other code. As a matter of fact, all kinds of code, whenever you have a different hierarchy of code or a different block of code, we wrap around that code basically with curly braces. So we have an open and closed curly brace. And those braces actually indicate to the C# compiler where a particular function begins and where it ends. And it allows us to actually have a nice hierarchy of our code so that we get beautifully formatted code, as I like to see. We then further organize our code up into different layers. So we have the basic function with curly braces, and then we have a collection of functions generally defined in what we call a class. A class is a collection of functions that are categorized or grouped together around a particular type of task. And again, just like we had the main function with curly braces, we're going to have a class library referenced by curly braces. So we'll have an open and closed curly brace for that as well. And then in some cases, you might want to take it even a step further when you say, I have not only just a set of methods and functions that are grouped together into a class, but I might have a series of classes that are grouped together into a logical unit that we can organize that we call a namespace. And a namespace is technically it isn't anything to the code, but in reality it's a human way of organizing the system much easier than if we had code without it, because we might want to organize our namespaces around certain things like a company name or a project name or a set of libraries for a particular kind of task. And in that case, you can categorize it and name it with these multiple levels of namespaces that help you organize that and make your code more succinct and to the point. Now, once we have a basic understanding of these constructs, we can then start building an application. And the simplest type of application that you would build is something like a console application. A console application is an application that simply runs inside of one of the command windows or the command prompts, or DOS prompt, if you will. And the only interaction with it is the ability to actually type in the name of the command on the command line, and when you hit enter, it will execute. Optionally, you can have it have input and output, The input would be what we call command line arguments, and the output would be simply text returned back to the command window. And this is the simplest of all types of applications. And we're going to start off today's session with actually building a very simple console application. So to begin, I'm going to go out and show you a very basic application structure, and then we're going to move that into building a very simple console application, just to give you an idea of what a C# application looks like. Now, when I move to the next screen, it's actually going to share out my desktop. And if you hit your F5 key on your keyboard, that should maximize your display so you can see the entire screen. Now, this application that I have here, I'm using a very sophisticated and powerful editor called Notepad, which simply allows me to type in text. And in its simplest form, an application that you can write, any application that you want to write for C# can actually be done in Notepad or any other editor that you want. And we're going to see today, as I build these first apps, that we're going to use we're going to use that very simple concept of a command line editor or a command line compiler to build applications that we've simply written with this text editor. So when we start off by looking at this application, you'll see some very simple organization here. And you'll notice that we have a nice hierarchy of objects here. So as I select my namespace, you'll see that we have the open curly bracket and the closed curly bracket. And then within that we have a class that has the same construct, the open and close. And then within that we have methods that have the same construct, the open and the close. So as we dig down further into this, you'll see that any type of looping or any type of function that you want to separate from something else, you're going to use these open and closed curly braces. And the C# compiler is very nice for us. It will let you know when it expected to see a curly brace and didn't see one. And we'll learn later on, for example, when we do for loops or if statements, that there are certain scenarios where you think you need a curly brace, but you don't really. And in fact, there's no actual code that actually goes on with a curly brace. It's simply there to help us humans organize what we're seeing. There's really nothing technical about it. The other thing that I want to point out in this little demo application, this little pseudocode application, if you will, is that this application, if you compiled it and all the code was real, would work just fine. However, I want to point out a few different things in here. When we declare our own namespace, we simply use the keyword namespace, and then we give it any friendly name that we want to give it. Within that, we can define our own classes, and our classes can also have their own friendly name as well. Now, a class is a definition of an object that you're going to use later on. And sometimes you might want to build a class that is similar to another class that you already have. So, for example, maybe what you're building is a person class or an employee class, and that employee class is actually a type of person. So in this case, what I'm doing is I'm defining this my class as a type of this parent class. So if I was building an employee like this might be a person class. So this employee is a type of person, and that's what this colon indicates, that we already have a class called person, and I want to change it ever so slightly to make it an employee. And that's what this class would actually do. So this is an instance of an object-oriented technique that you'll learn later on called inheritance. So we're going to inherit, this employee is going to inherit all of the properties and aspects of a person object. So it can be a person, be treated as a person, if you will. Within a class, like I said earlier, we have a collection of functions that are available to support what that class does. Those are the individual snippets of code that do the work, if you will. And those are defined in what we call methods. And this method here is a magical method, this method main. This is the primary method that all C# applications need. It is the entry point to your application. So every application that you build will have a main entry point, and that's called main. And the signature that you see here, static void main, is pretty much what it's going to look like. You might have some optional information here. So for example, you might have an event args array stuck inside here somewhere. where a user might pass command line parameters into your application, and those would be filled inside of in the parentheses here. And then once they're in there, then you can start using them in your code. But in our sample application here, we have something very simple. We have a single method call called other function. Another function is actually defined within the same class here, and its definition is here, and it's simply calling into this other function that's from this reference namespace. Now, I talked about namespaces and why you would have them, but in addition to that, you need to know how to use them. So how do you use code that's stored in another namespace? Well, that's simply done by using this using reference up here. So we use the keyword using, and then we give it the name of the namespace that we want to use. Once we have that, we can start calling into the classes and methods, so the classes and methods that are in this reference namespace. Now, there's going to be some additional work that you need to do to the compiler to let it know that you want to compile in this additional reference namespace into your application. However, from a coding standpoint, this is all you need. And in fact, now that we have the reference namespace in there, we can actually shortcut this and say, and just remove this portion of it because we already have the name referenced. So we're saying we are using code within here, and if there is no other class called class, then this would work just fine. So this gives you a real basic introduction to the structure and what you would expect to see in a C# application. I do want to point out that while we're looking at this code, there are a couple instances of some punctuation marks that are different than what we've seen if you might have used, for example, Visual Basic or something like that. In this case, C#, being based on the C language, actually has all line endings with a semicolon. This actually lets us know that we're at the end of this line of this statement, except in the case where it's not actually a statement. So other function in this case has a semicolon, which is a statement. The same thing with this reference code here. However, this line here, static void other function, is simply a definition. There is no executable code there. So without being executable code, there's no need for a semicolon. In fact, instead of the semicolon, we would have the open and close curly braces instead, indicating that there is more functionality in between these. So that gives you a quick little overview of what a C# application is going to look like. Now let's go ahead and build our first one. So I'm going to exit out of here. And what I'm going to do is I'm actually going to open up a new instance of Notepad, and I'm going to just create a new application. So since we're building a console-based application, console apps indicate that we're going to be using text-based interfaces. And Windows, specifically the .NET framework that we're building applications against, contains a set of libraries that allow us to use certain functionality within Windows that's built in. And those namespaces that contain that code are a part of the .NET framework. The primary one that you're going to use for almost everything that you do in C# is one called system. So we're going to use the namespace system, and again we're going to end that with a semicolon. And in addition to that, when you're doing text-based input-output, we're going to use a namespace called system.text. So I'm going to additionally add system.text to my code. So those are the first two things that we're going to be using inside of our application. Now the next thing that I want to do is, optionally, I could, if I wanted to, I could define a namespace. But since my application is so simple, and it doesn't need any additional external, interfaces, and nobody else is going to be using this, I can actually skip this. Because remember, a namespace is only there for humans' readability. In our case, this simple application that we're going to be building, we don't really need one. So we're just going to jump right into the class. And we're going to define a class called Hello World. All right. Now, in our Hello World class, we're going to have an open and close brace, and everything that we write is actually going to be inside of that. Now, remember, the very first method that we need, the primary method that we need in any application, is a method called main. And we're going to type in a couple keywords before that: static void main. And the reason I type in static and void is has to do with the way this application is actually being built. In this case, the main routine is a function, and in C#, all functions have to have some kind of a return value. In other words, they have to have some resultant value come out of it. However, if you don't need to do anything with that result, you can simply ignore it. And the way you ignore it in C# is you use the keyword void. So any function that returns nothing would look like that, void main. But what we want to do is we want to have an application that's available all of the time, no matter when we're using it. We don't want to have to create an instance of this Hello World class. We just want it to be available to us all the time. Generally, when you're writing applications and you're building an object-oriented application, you would want to have the ability to create and destroy objects so that you can maximize your memory usage. However, in our simple case, we just want to build an application that does its function and then totally exits out. So what we're going to do is we're going to use the keyword static, which basically tells Windows that when it runs this application, go ahead and create an instance of this Hello World app so that everybody can use it, and then do whatever work you need to do. So in our case, what I'm going to do is I'm simply going to call into the system.text namespace and ask it to display a message to the world. We're going to do that through what we call a console. So the console is basically the text box that or the command window that we're going to be dealing with. So console.writeLine, we're going to write a line out to the console called Hello World. Again, we'll end it with a semicolon. So in this case, I have a very, very simple application. In fact, this application is complete. So if I save this, and we'll just save this out as our Hello World console.cs. C# files end with a CS extension. So we'll change that to an all files, save. And when we go out to our directory, we'll see that we now have our Hello World console.cs, and I can type that out so we can see all of the source code. I can then go through and compile this application. Compiling it is basically taking it from the human-readable text and converting it into the assembly language, or the machine language that the computer understands. The .NET framework, when you install it, actually installs the compilers that it needs for Visual Basic and C# out of the box, and you don't have to install them or do anything in addition to it. You can simply start using them. However, they are actually in the Windows directory under a direct subdirectory called Microsoft.net, and then further down into other subdirectories underneath of that. And what I do is I actually set up a path statement, and I add on, if you look at the very end of my path statement here, you'll see that I've added the Microsoft.net framework version 2 to my path statement so that we can get access to those compilers without having to add the full path name in front of it. So what I want to do now is I want to compile that, and I'm going to use the C# compiler, CSC, and I'm simply going to compile Hello World console.cs. And when I do that, it's going to go through it. It's not really going to tell me anything except the copyright information. But when the output of that is actually going to be an executable program called Hello World console.exe. So if I just type in Hello World.console and hit enter, you'll see that the resultant output is Hello World, the text that we were expecting. So that's a very, very simple console-based application, and it did exactly what we told it to do. It used the text APIs from the system.namespace, and it wrote out to the console the text Hello World. And that's the entire extent of our program, and obviously it worked perfectly. So let's go back to the slide deck here, and let's take this one step further. We are generally running our applications in Windows, and when we're running them on Windows, we have the ability to take advantage of the APIs that Windows also provides us to build more advanced features. And most applications have the default look and feel of the operating system that they're run on, and that is exposed through us as a developer through what we call the system.windows.forms namespace. Those Windows forms give us the standardized look and feel of Windows by providing us what we call Chrome, or the outline, the border of the application, the minimize and maximize button, the close button, the control menu, and a title bar, and all the other features that a Windows form, a standard Windows window would look like. And the way we utilize those is we simply take our application, and instead of basing it off of a text console, instead what we do is we inherit from a library that has already been provided for us in the system.windows.forms namespace called form. So we can simply specify our application should inherit from an object that's already there called a form. Now doing that allows us to automatically, without any additional code, start inheriting all the features of those Windows forms that you get. And one of those features that you get is something called a title bar. The title bar is at the very top of the window, and it has the name of the application or whatever else the developer wanted to put into it. And what I'm going to do is I'm actually going to build an application that simply sets the text of that title bar so that we can see the same kind of output that we saw in our console application. So to do that, I'm actually going to go back out and build another application, very similar to the application that I just built, but I'm going to use a Windows form. And in fact, I'm actually going to write two different variations of it for you so you can get a good idea of some of the features that are out there. So back over into our application, I'm actually going to go ahead and save this file. Actually, we're going to exit out of this file. We've already saved it. Let's type in a new one, so Notepad. And this one's going to be called Hello World Window.cs. Cannot find, we'll create. And just like we did in the previous, we're going to use the system.namespace. However, differently from the previous one, instead of using system.text, we're actually going to use system.windows.forms. System.windows.forms is the namespace that has all of the APIs related to those forms. And again, just like we did before, we're going to have a class definition. So let's make this static class. We'll call it Hello World, just like we did before. Again, open and close parentheses or brackets here. And then inside here, we're going to have another static void main. So this will be just like the application that we did before. However, we're going to make one slight modification here. Instead of using a console.writeLine, I'm going to start off by doing a system.windows.form. We're going to use a message box. That's a built-in window as a part of Windows, and it has a method called show that allows us to type in text, hello world. So in this case, I have my application is using the system.windows.forms namespace, and we're calling the message box function in that to actually display our text. So if I save this, I can go back out and compile this, tsc hello world window.cs. And again, I now have a second application, hello world window, and I can run it, hello world window. And you'll notice that when I run it this time, I get a window, a standard Windows dialog box that has an OK button. Even though I didn't program in the OK button, the hello world text is displayed in the center here, and when I click OK, the application exits. That's because the message box actually contains a bunch of features that allow us to utilize the built-in functionality of Windows to make our application look any way we want. And in this case, I wanted it to look like a message box with a single OK button. Now, this show method actually contains a whole bunch of additional parameters that allow us to customize the look and feel of this. But what I want to do instead is I actually want to show you a little bit more detailed application. And in this case, I'm going to comment out the message box, and instead I'm going to build another class that actually defines what this application should look like. So here we have the static class called Hello World, and now we're going to go down here, and I'm actually going to create another class. This one's going to be a public class, which means it's accessible by everybody. It's going to be called class, we'll just call it my form. And my form is actually going to inherit from the system.windows.forms namespace. There's a class called form, spelled form. And in this class, what we're going to do is we're going to go ahead and create an instance of it. We're going to use this code to create an instance of it. And we're going to actually create a, using the constructor. to actually spin up an instance, we're actually going to have it display its own text instead of the message box. We're going to build our own form that contains its own functionality. So to do that, we're going to have a public constructor called myForm. And in fact, I need to open and close parent on this. And our constructor is simply going to have this.text equals hello world. Now, this keyword this is actually a keyword in C# that basically says, hey, whatever application I am, my current instance or my current window, wherever this line of code is executing, in this case it's in the myForm class, it's going to set the property of that form, which form actually has a property called text. It's going to set that property to this new value of hello world. If I didn't set this property, it would be whatever the default text was for that class. But in our case, we're creating this new instance of this form, and whenever the new instance is created, it's going to go automatically and set this property. So that's what this method right here does. In fact, when you create a method in C# that is the same name as the class, that method, you'll notice it has no return value, but that method is called the constructor. It is called whenever an instance of this class is constructed, all of this code will get executed. So that's what that guy is doing. And now what we need to do is, instead of displaying our message box, we just need to have our code basically show up or start up an instance of this new form. Now, when you're building a Windows form, if you don't have a message box that holds its own, in other words, it pauses the screen and stays there, what you're going to wind up with is an application that launches and then immediately shuts back down. So we actually have a special mechanism built into C# that allows us to actually create an instance of a form and wait until that form gets destroyed by the user. In other words, the user exits out of the application before the application actually exits. And we have an application object that actually has a run method on it. And in this case, it's going to run a new method of myForm, a new instance of it. So it's going to create a new instance of this, and it's going to hold on to that instance until this guy actually destroys itself. In other words, the user exits out. And I'll show you how the user exits out of this as we run this. So there's our entire application. By the way, these two slash marks are a comment out. I'm basically commenting this out and telling it to ignore the rest of this line. So we'll go ahead and save this. We'll go back over to our app, and I'll recompile our app. And again, we now have the same code that we had before, and I can actually rerun our app, the console window. And now you see, instead of having the standard hello world in the dialog box, the message box dialog box, I have a standard Windows form that has all of the other Chrome features with it, with the text set as hello world. In fact, it has the control box here with all the minimize, maximize, move, and everything. It has the minimize, maximize, and close buttons, as well as a resizable window. So I can change the size and move it around. And I get all of that for free simply by using the instance of this. Now you'll also notice in the command line down here, I've typed in hello world window, and it's paused. It hasn't returned. It's waiting for me to close this window. And it won't do that until I choose the exit, either close from here or X here or any other standard Windows way of closing the app. But when I exit out of here, you'll see immediately once I exit out of here that the command line will come back to me in Windows and in the command console window. That's exactly what it did. So that's how we actually enter and exit an app. Now I want to point out, if we go back to our console application and we rerun it, you'll notice that it immediately came back. It immediately returned to me. And that's the difference of the application run and the non-application run version of it. So that shows you a very, very simple example of a client-based application running in Windows. Now, any other type of application that you would build that is going to be running on a piece of hardware from the client's perspective is generally going to be this type of an application or a derivative of it. For example, if you're building applications for Windows Phone 7, Windows Phone 7's primary development platform is Silverlight, and Silverlight is a type of application similar to this Windows Forms. The difference being that instead of developing your code, developing your UI in code, you actually develop it in another language called XAML using some tools. And then you can run this type of code behind it. But in reality, it's a client-based application just like this is. Other types of applications would be an XNA game. So we have a tool set called XNA that allows you to build games for the Xbox 360, for Windows Phone, for the Zooms, and as well as for Windows. Those are also types of client-based applications. And you'll find that the only differences between this application and those applications are going to be in the types of namespaces that they use. So for example, the Windows Phone would be a XAML namespace. We have system.windows, but there's not a forms class. The XAML is another type of system.windows that's different from forms. And then the XNA would be a Microsoft.xna.game class. So they would inherit from that as well. So those are some interesting things that you'll find out as you go through learning this, this type of coding. Okay, so back over to our slide deck. And there still are no questions in the queue, so I'll go ahead and move on. We just talked about Windows forms. We talked about console applications. The third type of application is what we call a web form or a web page. And basically a web form is a very simple version of a web page that has not only the HTML elements that web pages have, but it also has Visual Basic or C# or whatever types of code behind the scenes to help it support what it needs to do for the page, to make it more active. Now, instead of the application inheriting from system.windows.forms, a web page is always going to inherit from system.web.page, all contained within the system.web namespace. So when we build our application in C#, we're actually going to build it either in a web page itself, or we're going to build a class that inherits from that page, the system.web.page. And then once you have that, you're then going to pass that off to your web server. You're going to store that page on your web server, and whenever a call comes into your web server for that particular page, the web server is going to see the ASPX extension instead of the VB or CS or EXE. It's going to see that ASPX extension, and it's going to know to pass that off to ASP.NET. When ASP.NET sees it, it's actually going to compile that page by itself. So we're not going to use the command line to compile these apps like we did before. Instead, we're going to let ASP.NET and the web server handle the compilation of our applications for us. And then what's going to happen is instead of us using a command line or a window, we're going to make our requests for the web page via the URL of the web browser that we're using. And then the ASP.NET is going to take whatever output that we have, and it's going to send that back through the response object back to the consumer, back to the client browser window. So that's kind of how web forms actually work. So we're going to build a very simple web form, and instead of building it like the traditional web form, or I'm sorry, Windows form or console-based application, we're actually going to start off by building an HTML page and testing that, and then adding our additional functionality to it. So let's start off by creating a new web page. So Notepad, hello world. I'm just going to call it hello world.html, and it's going to go ahead and create that. So we'll start off by doing the classic HTML elements. So we have our head tag. Head has a title, hello world. And then we have a body tag. And within our body tag, we're going to go ahead and put a couple elements. There's a div tag in here that allows us to separate, our text. This is where it's going to be. And then one additional feature that we're going to need is we're going to actually, because we're going to be dealing with interaction between the client and the server, in HTML we actually have a mechanism called a form that allows us to pass data back from the client to the server. So our form is actually going to be, we'll just call it form right now, and at the end here we'll have a end form. Now if I save this, I could actually open this up in a browser. I can do simply a start hello world.html, and that's going to launch the browser and show the output of that, which is going to be our text. So that's actually a very simple application, but it's going to allow us to, we're going to take this now and extend that out and add our ASP.NET functionality to it. Now, in ASP.NET, whenever we want to add functionality to a page, we do it in a special type of attribute like this, and the attribute is actually a percent sign. So all of our code is actually going to be in percent signs like this. And when we're defining a page in ASP.NET for C# and even for VB, for example, whenever we want to define it, we're going to start off with the @ sign, and we're going to say this is a page, and its language is going to be C#. Okay. So everything within this page, any code that you see inside these percent brackets are actually going to be written in a language called C#. And this derives from the ASP.NET page called page, or a class called page. The only other thing that we're going to do here is we're going to actually specify that our form has an ID. We'll call it form 1 just for kicks. And then it's going to be run at the server. Now what this tells ASP.NET is whenever it sees this, any code that it executes is actually going to be executed on the web server as opposed to being run on the client. I could also have code that runs on the client embedded in here, but that's for another session. Now the only other thing that we want to do here is we simply want to return the response hello world. Again, we're going to have our code within our brackets, and we're going to simply tell the web server, hey, we would like you to respond using the response object, response.writeLine, similar to the console that I did. In fact, I'm just going to do that, right? Hello world, and with a semicolon. So you can see here, this line of code by itself is pure C#, and it's wrapped around, it's embedded in this percent bracket, and this percent bracket then gets interpreted by the rest of the page. So when I save this, actually we'll save this as an ASPX page. Let's change the extension to .aspx. If we see here, now we have our hello world.aspx page. I can't exactly run this here. This has to be run within the context of the web server. So what I'm going to do is I'm actually going to copy this hello world.aspx page, and I'm going to copy it over into my web server. So I'm just going to go out to my desktop, to my soup to nuts demos folder, take my hello world.aspx file, copy this. Actually, let's just extend this out, inetpub www-root. So we're going to copy it into there, and there we go, we have the file. So if we view this open, we can actually go through here. Actually, we already have that there. That's already open. So we have our file. Now all I have to do is to open this up in my web browser, and I happen to have my local host already set up here, and I can simply type in hello world.aspx. So when I hit that and run that, it returns my hello world text to me. So hello world is the text we typed in. We had it respond with that, and now we have our code actually executing on the web server. So this gives you the example of building a web page, utilizing it to actually process code on the server and return the results to the client, whereas the console application and the Windows application were actually code running on the client itself. Now you can actually build applications that take advantage of this and combine these features. So you'll see later on that, for example, this hello world.aspx has a human interaction through a browser, but it can also have a service-based interaction through an API that a console or a window or a Silverlight or an XNA app can actually consume. So you can have a client application calling into a server-based application and actually sharing data. And this is, in fact, how most applications work that are on, for example, mobile phones. Take, for example, a mobile phone that has a Facebook client on it. It doesn't use a browser on the phone. Instead, it actually has a client on the phone, and that client actually calls out to some service on the server to get its data. And that server is going to be supplying its data in a very similar manner to this web page. Though this is a very simplified version of it, essentially it's the exact same concept. So hopefully this gives you a good idea and a good understanding of the types of applications that you can build with C#. And it gives you an idea of kind of the direction that we're going to be going with this. Every application that we're going to build from this point forward is going to be a C# application of either a console, a Windows, or a web-based application. And we'll take a look at some of these other types of apps, but just to show you that they're basically the same type of apps, and that the coding, the concepts, and everything else are similar across all of the different platforms. So that's actually all I have for this week's session. Next week, we're going to actually introduce you to a tool that's more powerful than Notepad called Visual C# Express. Visual C# Express is actually a free download that you can get that allows you to build C# applications. And we're going to take a look at a lot of the features inside of that application that allow you to not only edit your code, but also to understand what's right and what's wrong with your code, help you debug the code while it's running, actually help you even code it by speeding up the coding through some technologies like IntelliSense that help you with getting the names right of certain functions and the locations of where they're at and things like that. And then we'll also talk about how Visual Studio and Visual C# Express actually organize your application into the collection of files that it has into the single output executable that you were trying to build. So that's all next week. And then continuing on from that, we're going to have a whole bunch of other webcasts around the different types of constructs around the language, what kinds of functions are available, what kinds of operations can you do, and how do they work. And we're going to look at all of those starting next week. I want to thank you guys all for coming. This is my contact information. Please feel free to send me any questions that you have even after this session to my email address, wsteele@microsoft.com. And take a look at my blog, blogs.msdn.com/Steele, where I'll have actually all the source code for these demos, as well as the links to the slide decks and things like that out there. And then lastly, follow me on Twitter at WJSteele. And at this point, I'm actually going to turn it back over to Ari so he can get you into the survey results. Please, please, please fill out the survey and let us know what you think about this session, as well as some of the ideas that you might have for some of the upcoming sessions. Ari?
Thanks so much, Bill. Just a reminder, if you do have any questions for Bill, please go ahead and submit those and he can get to those, or you can always submit those offline later. You can print out the PDF of these slides by clicking Control-P. You can save them locally as a PDF or print them to your machine. Right now you should be seeing a survey in the slide area, and if you can take a moment to fill that out before you log off, that would be great. We really appreciate any feedback you leave for us. All you need to do is follow the links provided, and that'll take you to the survey. Bill, before we wrap up, are there any last comments or notes that you want to handle?
No, I don't have any about today's session. I want to thank everybody for joining me, and don't forget that every Thursday, same bat time, same bat channel, we'll be continuing this webcast series. And if you're also interested, we have a very similar series that occurs 2 hours before this on Visual Basic. So the VB.NET Soup to Nuts series, we're doing them paired together. So every day we'll do the same code, same concepts, but the 2 different languages throughout the entire series. And I think there's about 22 or 23 different parts to this webcast series. So we'll continue well on into next year, our next fiscal year, with this series.
That's great. Thanks so much, Bill. Everybody, thank you, Bill Steele, for today's presentation. Please do take a moment to fill out the survey before you log off. Thank you all for joining us, and you can now disconnect from the audio portion of this conference.